Hello and welcome guys. So in the last video we have seen the model evaluation. So before model evaluation we have seen how we can reload our model using TensorFlow. Like while performing training we have saved this model, and also we have saved this training history because it's a very time taking process, so we can't do this process again and again. So we have saved that training history in JSON file and model in the form of h5 and keras file. So we have seen that how we can reload that model. Also we have seen how we can reload the history, and we have reloaded this history and model, and we performed a model evaluation. Sometimes there may be a possibility that you are getting good accuracy, but you are not getting good precision and recall. So precision recall is also one of the metrics to measure the performance of any machine learning model. So it's very important to evaluate your model based on accuracy metrics and also based on precision recall metrics. Precision recall basically tell you that how powerful or how robust your model is on different classes. Okay, I already explained you precision recall in my plant disease playlist. So if you want precision recall, then you can go here. Or AI is also explaining that precision recall are metrics used to measure the performance of classifier in machine learning. So this is the image. This is very good example you can see. So precision is basically the sum of all true positive value upon total true positive and false positive. So whatever is positive, like whatever is total positive prediction done by the model, like if we are calculating the precision for this positive true positive prediction, that is that prediction whatever and done by the model is actually positive, actually belongs to this positive class, and your model is also predicting that it is positive, so that is true positive. And false positive is that your model is predicting that it is positive but it's actually negative, so that is false positive. Okay, same is negative. So this is the predicted area and this is a real label. So if you see, this model is saying that it is positive but it is actually negative. Okay, so that is false negative. And if your model is saying that it is negative but it is actually positive, then it is false negative. Okay, and if model is saying that it is negative and it is actually negative, that is true negative. So this is what the meaning of this true positive. This entire thing I've explained in detail in my plant disease playlist. So if you go in the model evaluation, that precision recall part of plant disease playlist, then you will see the application of this I have used there also. So this is a formula of precision and recall, and to calculate accuracy you have to take this this is a formula. Okay, so this is what the precision recall is. Okay, so by using this we can say that how robust our model is on this positive class and negative class. So same for our problem, we have 10 class. In this example it's actually 2 class, but in our case it's 10 class, so we have to calculate precision recall for all 10 class. Okay, so first, before that, we need ypredict, because we are going to use here scikit-learn library to calculate the precision recall. So first we need ypredict. So before that we have to see that whether we have test set or not. So this is our x test. Like if you are running this entire thing, like I'm running after 10 days. So if you are running this project after some time, like you have stopped here and you are starting this video after some time, then what you have to do, then you have to run this cell. First you have to import all the required libraries from here. Okay, and after that you have to come here, data pre-processing part, and you have to run this cell. You have to reload your classes data directory, and you have to perform this data pre-processing again. Okay, so you have to execute this function again, and you have to record all the data in this data variable and labels, and then you have to transform your labels into categorical form in one hot encoding form, and then you have to reload xtest, xtrain, ytest, ytrain. Okay, this thing you have to reload. After that you don't have to run this building model. Okay, just reload it and come here after that. And also you have to reload your model. Okay, if you have not reloaded your model, then you have to reload your model. So for reloading part, I have already given you, you can reload your history also if you want to reload. So reloading model variable, so by running this you can reload your model variable. So this is how we can reload. If you want to reload your history, then you can reload your history also. So you will get your history in this training history data. Okay, you can run also this one also. You don't have to run these things, we have done this in last video. So we can start fresh from here. Okay, so before that, let me give here one markdown as, so escape B. Okay, and here escape M and give here markdown. So I am giving here markdown as precision recall, and one more thing we will do here, that is confusion matrix. These are some metrics we will use. Okay, model evaluation, I am writing here model evaluation. This is another way of model evaluation. First one we have already done, this one. Okay, this is part 1. We can give here like this. Okay, this is part 1 and this is part 2. Okay, this is part 2 of our model evaluation. So first we need X test. We have our X test here. Okay, you can see the shape of that X test also from here. Okay, this is the, so we have 2995 training examples of shape 150 cross 150 cross 1. Okay, so this is the matrix we have. So first we will compute y predict. Okay, so y predict will be, to calculate that we will use function model.predict and we'll pass here X test, and we can see our y predict from here. So it's calculating our y predict. So we'll, yeah, this one. So this is our y predict. Okay, now we can see the shape of this also. So this is the shape, we are getting this much. So basically this is we have this much of training example, so this many number of rows we are getting, and this is 10. So 10 columns we are getting. Each columns are representing the probability that example belongs to which class. Okay, so our model is predicting that this much is the probability that it belongs to first class, and this much is the probability that it belongs to second class, and this much is the probability it belongs to third class, and so on. Okay, so we are interested in, like, what is our prediction? So our prediction will be the maximum probability out of this 10 class which we are getting for each training example. Okay, so what we will do, we will calculate the predicted categories. We are not interested in this probability, we are interested in that class. Okay, to get that class we'll use numpy and np.argmax we will use. So this np.argmax will return the index of maximum value out of that matrix. So that's why we are applying this. So we'll apply this on ypred, and axis we will do axis is equal to 1. So axis is equal to 1 means vertically iterate over each columns and extract the maximum index out of it. Okay, and if we do this x is equal to 0, then it will iterate horizontally. Okay, it will iterate row wise, and it will give us the maximum value out of this 2995 rows. Okay, but right now we are interested in iterating over each columns, so that we get one value for each examples. Okay, that's why we are writing here axis is equal to 1, so that we can iterate over column and we extract the index of that column which is maximum. Okay, so this is our predicted categories. If I print it, then we will get this one. So if you see this example, then this is the maximum, where this is the 0 1 2. So this is the maximum value which we are getting. It's actually 0.94. So our model is predicting that first example belongs to this 0 1 2, which is third class. Our model is predicting that first example belongs to third class. So our index start from 0. So 0 will be first class, 1 will be second class, and 2 will be third class. Okay, and for second training example, which is this one, our model is saying that it belongs to ninth, that is last class. So our model is predicting 0.988 probability that it belongs to this class. Okay, second training example. So like this, or we are getting the index of our classes. Okay, so we got our predicted classes. Now we will and we have our now we need y test. Okay, y true. Okay, we have to give here caps y. So this is y, this is our y true. Okay, and also we need classes. So this is our classes. Okay, this is 10 classes. And now what we will do, we will use the scikit-learn library. So first I will import here from sklearn dot matrix. We will do, we will import first confusion matrix. Okay, confusion matrix, and second will be classification report. Okay, these two things we will use. And to calculate confusion matrix, we will use this confusion matrix and we'll pass true categories. Okay, we need true categories and predicted categories. Okay, so first we have to compute the true categories. Okay, so here we have calculated this this thing, but if I do here the shape of this y test, if I do here shape of this, then it's like this. So we have to transform this in this form like this. Okay, like we have our y predict like this, so we have transformed that y predict like this. So we also have to transform this y test. Okay, then only it will accept y because here it will accept true value and the prediction value. So what we will do, we will calculate true categories. So to calculate true categories, we will use same thing, np.argmax we will do, and here we will write y test or y test, and again we will do here x is equal to 1. It means that we are interested in maximum value, maximum index, like in 0 and 1 will get 1. That's why I am using this. So if I hit it, and it's giving me like this. Okay, so if you see, our prediction is wrong here. In first, our prediction is wrong because it's giving true categories is 7 and we are getting 2, so it's wrong. Okay, so first two predictions are wrong, and if you see, this one is right and this 14 is also right. Okay, so we are getting 90% accuracy, so that's why it's in 10%, I think. Yeah, so first you have to pass your true categories, and second you have to pass predicted categories. Okay, predicted categories. Okay, and same format is also required to calculate precision recall. So precision recall f1 score. So for that I am printing classification report and I am writing true categories, and second thing I am writing predicted categories. Okay, and third it will require, if I go to the documentation like classification report scikit-learn, if I go here, then you will see they have provided a very beautiful documentation. It will accept y true, y predict, and labels. Okay, this is what it will accept. Okay, labels, in place of labels you can also give target name. Okay, so I will give here target name. Target name is equal to, here I will give my classes. Okay, so by like this we have to give target name will be our classes which we have defined. Okay, let's run this. So if I run this, then it will print me this classification report, which we are getting classification report for each classes. So for each classes we are getting precision recall and f1 score. So by seeing this, you can like do an analysis that how your model is performing on each classes, how robust your model is with respect to classes. Like if you see, for country audio, it's not good, like as compared to blues and classical. For blues and classical we are getting 95%, and this recall is here, if you see, recall is less. Okay, so by seeing this, you can you can see and you can come to some conclusion that how your model is on each classes, and you can also improve this performance by tuning your model, or by tuning the data pre-processing part. You can improve this thing also. Okay, so now we will do the confusion matrix visualization. So if I print this CM, so this is our confusion matrix. So this is what we are getting. Now we will visualize it so that we can see it like more clearly what this entire array represent. Okay, so for that we will do the visualization. So import cborn as SNS we will do. Okay, so it's running. Okay, fine. So we have cburn library. If you don't have cburn, then you can install it by doing pip install. And if you want to install in this current environment, then you can simply do from here also pip install cburn. If you execute this cell, then you will be able to install cburn, as it's showing here requirement already satisfied because I have already installed cburn. Okay, so this is how you can install cburn. So now what I will do, I will try to create figure, plt.figure. So this one, yeah, and in this I have to give fixed size. So fixed size I will give 15 cross 15. Okay, fixed size I will give, and I will use cburn sns.heatmap to plot my confusion matrix. And first argument it will take as matrix, which is cm, and that's it. And at last I will do plt.show. So if I run this, then we will get this type of matrix. Okay, we are getting, but the numbers are not visible. Like this is the 0 1 2 all the classes, and this is also a class. So we have to represent it. We have to give proper label here. So first we'll give a plt.x label. Plt.x label I will give. And what is this x-axis? X-axis of confusion matrix is predicted class, and y-axis will be plt.y label, and it will be actual class. As we have seen in the precision recall part, x-axis is a predicted class, and this is x-axis. You can give anything, like it can also become real and it can also become predicted. Okay, so x y you can give any one is predicted and one is actual. Okay, fine. If you go by this also, like by this also, then you will get the same thing. So no issue because it's square matrix. Okay, so it's actual class. Okay, if I run this, then you will get here actual class and predicted class. Okay, and but this font size is small, so we can increase this font size by giving one more parameter here, which is our font size. Okay, not font dict, font size. It's not taking. Okay, I will give right like this. Font size equal to 10 I will give, and here also font size is equal to 10. Okay, let's run this. Next argument I will give as plt.title. What is this graph? So it's a music genre classification confusion matrix, and I can give font size of this also. Font size I will give here 15. So this is a music genre classification confusion matrix, and I want this number to be represented here. Like in graph I want to show that what exactly how much is the value. Like if I here if I show you this one in cm matrix, I am getting there here 238, but here in this visualization there is no number. So I want to display number here. So to display number, we can give here annote is equal to, we can give here true. If I run this, then we will get here number. Okay, so annote is equal to true, and I want to give here annote keyword also, this one, and in this keyword it will take dictionary form. In dictionary form I want to give size, and size I want to pass as 10. Okay, so if I run this, then I will get this much of value. Okay, so it's showing that 2.4 e, it means that it's approx 240. So this is what we are getting here. Okay, so this is how we can represent our confusion matrix. I think we have completed this. So this confusion matrix denotes that a majority of elements lies in this diagonal part, so it means that our model performance is good. Okay, so sometimes we are getting this 27 and this value, so we can make it more robust by tuning the parameters of our model, like by changing the architecture of our model. This model architecture, if we tune this parameter, we can add more layers, or we can tune this number of neurons, and we can add dropouts. We have to make more generalized function, we can do by modifying this model architecture, or second thing we can do by performing the data pre-processing, like by improving the data pre-processing part, we can also improve our model performance. So these two things we have to tune. Okay, by tuning this we can improve and make it more better. So right now what I am getting here, so it's also good, it's not bad. So this is what we are getting right now. Okay, so in this video we have calculated this precision recall confusion matrix. This is a part 2 of the model evaluation. So after doing this accuracy and all, model evaluation on accuracy matrix and data visualization of training loss and training accuracy, this visualization we have seen. So this is a curve which we are getting with respect to each epochs, and then we have seen the model evaluation. So these things we have seen here. Okay, and precision recall and confusion matrix. So this is the final part of model evaluation. Okay, so we have completed our deep learning model evaluation. Up to here we have to perform in this training music genre classifier. So in next video, what I will do, in next video we will perform a model testing. Okay, we will take some sample audio. Okay, because we have trained our model, we got our model, and we have successfully evaluated our model. In next video we will take some random files, and also we will take some files from internet. Okay, which belongs in these classes which we have, on which we have trained our model. We'll take some rock music or some classical music, and we will try to test our model on that audio, and we'll see how we can perform prediction by taking our model and by taking any random file from internet or anywhere. Okay, and after that, once our model testing is completed, then in final video of this playlist we will make a interactive web application which will take audio file and it will give you a prediction. Okay, so this is the entire plan for this playlist. Okay, so that's all for this video. Thank you guys, thanks a lot for watching this video. We will meet in next video.